this video, I'm going to talk about one of the applications of differentiation, that is rate of change. But in this video, I will focus in question involving volume of cone shape. So let's proceed to the example. Question 1. Water is dripping out from a container having the shape of an inverted cone at the rate of 0.8 cm³ per second. If the radius of the base of the cone is 12 cm and its height is 18 cm, find the rate of decrease of the height of the water level at the instant if the height of the water level is 6 cm. So, from the question, we know that the radius of the base of the cone is 12 cm and the height is 18 cm. And before we start, I'm going to define the variable that we are going to use in the calculation later. First, I use capital letter V to represent the volume of the water in the cone. And R represents the radius of the water surface. Then H represents the height of the water level. Then T represents the time in seconds. From the question, we notice that the water is dripping out at the rate of 0.8 cm³ per second. So this is dV dt. And since the water is dripping out, so means the value is a negative value. So means dV dt is equal to negative 0.8. And we are asked to find the rate of decrease of the height of the water level. So means we are going to find dH dt. And at the instant, if the height of the water level is 6 cm, so means H is equal to 6. So this is the information given in the question. To find the dH dt, now I'm using chain rule. First, I separate the variable H and T, and in between here, I put in another variable in this question, that is V. So, dH dt is equal to dH dV times dV dt. The value of dV dt is already given in the question. So, to find the answer, now I need dH dV. So, to find dH dV, I need an equation that relates H and V. Since V is the volume of the water in the cone, so V is equal to 1 over 3 pi r squared H. Now I try to differentiate V with respect to H, but I found that there is another variable in the equation, that is R. So before I can differentiate, so now I'm going to change R in terms of H, such that I can differentiate V with respect with H. To do this, I'm using the concept of similar triangle. So first, I convert the 3-dimensional diagram into 2-dimensional diagram. So this is the water with radius R and height of the water level. This triangle is the cone with radius of the cone is 12 and height of the cone is 18. And this is the common angle between the water and the cone. So for the water, the tangent of this angle is R over H. Compared with the cone, the tangent of this angle is 12 over 18. So when I simplify, I get R is equal to 2 over 3H. Now I can replace the R into the equation with 2 over 3H. So Now I get V is equal to 4 over 27 pi h power 3. So now I can differentiate V with respect to h. So dV dh is equal to 4 over 9 pi h power 2. And when I put it under fraction form, it is 4 pi h power 2 over 9. Now we have got all the information that we need to do the calculation. So to find dH dt is equal to dH dV times dV dt. For dH dV, from the calculation just now, dV dH is equal to 4 pi h power 2 over 9. So here we need dH dV. So means we need to turn the fraction here upside down. It is 9 over 4 pi h power 2 times dV dt is negative 0.8. Then when we simplify, we get negative 9 over 5 pi h power 2. And when h is equal to 6 and we substitute h with 6 and we simplify, we get dH dt is negative 1 over 20 pi. So now we answer the question that the rate of decrease of the height of the water level is 1 over 20 pi cm per second. However, if it is in another case where the radius of the cone and the height of the cone is not given, instead of that, we are given the angle of the end of the cone is 60 degrees. So in this case, to find r in terms of h, same thing, we are using the concept of similar triangle. But in this case, we use the angle of the end of the cone, where we are given the angle is 60, but because this is the half of the cone, so half of the cone here, the angle is 30 degrees. So based on this diagram, the tangent of 30 degrees is equal to r over h. Tangent 30 degrees is 1 over square root of 3. So means r is equal to h over square root of 3. So now when we replace r with h over square root of 3 into the equation of the volume, so when we simplify, we get V is 1 over 9 pi h power 3. And when we differentiate V with respect to h, that is equal to 1 over 3 pi h power 2. And we make it into fraction form, it is pi h power 2 over 3. Now we proceed to the second example. A right circular cone with radius 3 cm and height 9 cm and standing on its circular base is initially full of water. Water is leaking from the circular base of the cone at the rate of 2 cm cubed per second. Find the exact rate of change of the depth of water when the depth of water is 6 cm. So from the question we know that the radius of the base of the cone is 3 cm and the height is 9 cm. And first of all, of course, we are going to define all the variables that we are going to use in the calculation later. V is the volume of the water in the cone, and R is the radius of the water surface. H is the height of the water, and T is the time in seconds. So, from the question, we are given that the water is leaking out at the rate of 2 cm cubed per second. So, this is dV dt, and since water is leaking out, so it is a negative value. So dV dt is negative 2. And we are going to find the rate of change of the water. So means this is dH dt. And we are going to find dH dt. And when the depth of water is 6 cm, where h is equal to 6. So this is the information given. Now to find dH dt, we are going to use the chain rule where dH dt is equal to dH dV times dV dt. dV dt is already given in the question. Now we need to find dH dV. Now for the volume of the water, to find the volume of the water, notice that the shape of the volume of the water in this cone is not in cone shape. So means we cannot use V equals 1 over 3 pi r squared times h to find the volume of the water. So to find the volume of the water, first we need to find the volume of the cone and minus the volume of this empty part in order to find the volume of the water. So the volume of the cone is equal to 1 over 3 pi times r. R is the radius of the cone and h is the height of the cone. Then minus the empty part here. Since the empty part here is in cone shape, so we can use 1 over 3 pi r. R is the radius of this surface, water surface, and height. For height, we cannot use h because the height of this empty part, it is not h. So we need to find the height of this empty part here. So when we look at the diagram here, this part, the height is 9 minus h. So this is the height of this empty part. So means the volume of this empty part is 1 over 3 times pi r squared times the height of the cone shape, that is 9 minus h. So now before we proceed, we find that we need to change r in terms of h. Same thing, I'm going to use the similar triangle. So first I convert the 3-dimensional diagram into 2-dimensional diagram. And I'm going to use this common angle to do the compare between the small triangle and big triangle. And based on this angle, for the small triangle, tangent of this angle is r over 9 minus h. And for the big triangle, tangent of this angle is 3 over 9. So when I rearrange, I get r is equal to 9 minus h divided by 3. So now I can replace r with 9 minus h over 3 into the equation, and when I simplify, I get this volume of the water. So now I can differentiate V with respect to h. So when I differentiate dV, dH and simplify, then I get dV dH is equal to pi times 9 minus h power 2 over 9. So now I have all the information that I need to calculate dH dt. So now when I substitute the value of dV dt, it is negative 2. For dH dV, I get from the calculation just now. The calculation just now is dV dH. So for dH dV, I just put it upside down. That is 9 over pi times 9 minus h power 2. So when I simplify, I get negative 18 over pi 9 minus h power 2. So when the value of h is equal to 6 and I substitute h with 6, and when I simplify, it is negative 2 over pi. So, therefore, the rate of change of the depth of water is negative 2 over pi cm per second. Now the next example, water is poured at a constant rate of 10 cm cubed per second into a cup as shown in the figure. The upper and lower radii of the cup are 6 cm and 3 cm respectively. The height of the cup is 8 cm. How fast will the water level be rising when h is 4 cm? So from the question, the upper radius is 6 cm, the lower radius is 3 cm, and the height of the cup is 8 cm. So before we proceed, of course, we need to define all the variables that we need. V is the volume of the water, R is the radius of the water surface, H is the height of the water level, and T is time in second. So from the question, the water is poured at the rate 10 cm cubed per second, but since now the water is coming in, so it is a positive value. So this is dV dt, so dV dt is 10. And in this question, we need to find how fast will the water level being rising. How fast means with respect to time, that is t. So this one means we need to find what is the value of dH dt when h is equal to 4. So this is the information that we have. Now to find dH dt, we know that we are going to use the chain rule dH dV times dV dt. dV dt is already given in the question, so means now we are going to find dH dV. Before we can find dH dV means we need to find the volume of the water. But notice that the shape of the water in the container is not in cone shape. So means we cannot use V equals 1 over 3 pi r squared times h to find the volume of the water. But we notice that this cup actually is part of a cone shape. That is, when we extend the lower part of the cup here, so actually it is a cone shape. So now I convert the diagram from 3-dimensional into 2-dimensional. So when I extend the lower part here, now I get this one is a cone shape. So, and this is the upper radius of the cup, this is the lower radius of the cup, this is the height of the water, and this is the radius of the water surface, and this is the height of the cup. This part is extended such that it becomes a cone shape. So now means this part, the height we need to know. So now for time being, we label it as y. So based on this diagram, in order to find the volume of water, so by using the formula of volume of cone, so we can use the volume of this triangle minus the volume of this smaller triangle. So for the volume of the water, it is equal to 1 over 3 times pi. R is the radius of the water surface. Height of this triangle is actually h plus y. So this is the bigger triangle minus the smaller triangle, that is 1 over 3 times pi times r. R is the radius of this smaller triangle, times height is y. So, before we can proceed to find r in terms of h, we need to find the constant value y. To find the constant value of y, same thing, I'm going to use the concept of similar triangle. Since from the diagram here, there are 3 similar triangles. So to find the value of y, I only need 2 triangles. So I use the smaller triangle and the biggest triangle. So now, based on this similar triangle, I'm going to use this common angle to do the calculation. So by using this angle, for the smaller triangle, tangent of this angle is 3 over y. Then for the bigger triangle, for this angle, the tangent is 6 over 8 plus y. So when we simplify, y is equal to 8. Now, we replace y with 8 and we simplify, we will get something like this. So now, what we need to do is we are going to change r in terms of h such that we can find dv dh. So to do this, same thing, I'm going to use the concept of similar triangle. But for this time, I'm going to use the triangle involving the water and the smallest triangle. So I'm going to use this common angle to do the calculation. For the smallest triangle, for this angle, the tangent is 3 over 8, and for the bigger triangle, for this angle, the tangent is r divided by h plus 8. So when I simplify, I get r in terms of h. So now I replace r in terms of h, and when I simplify, I'll get something like this. So now I'm going to differentiate v with respect to h, that is dv dh. So after differentiate, dv dh is equal to something like this. So when we put it in fraction form, it is 9 pi times h plus 8 power 2 over 64. So now we have all the information here. So now we can calculate dh dt. So for the value of dv dt, it is given, it is 10. So for dh dv, we can get from dv dh and we make it upside down. So we get 64 over 9 pi times h plus 8 power 2 times 10. So when we simplify, we will get this one. And when h is equal to 4, and when we substitute h with 4, then when we simplify, we get dh dt is 40 over 81 pi. So therefore, the water level rises with 40 over 81 pi cm per second. So these are the 3 examples of rate of change, and I hope this video can give you a little bit guides about how to solve the questions of rate of change, especially in the cone shape. Thank you so much and thanks for watching.